So today's video is going to be about light. What is light? What is light? What are its properties? What it can do? And what is it used for? Plus the phenomena. What actually light is? We'll talk all about that. So first of all, light in simple terms, simple labor terms, we can say something. Here something is whatever you can say that allows us to see things around us. So imagine this is a bulb, and if this guy is someone over here and he has to see something, this box. Now the till light doesn't reflect on that bulb and reach that person's eyes, he won't be able to see that object. So the concept that people say when light travels to your eyes you see object, that's wrong. The actual thing is that the light will hit that object, and that object, the light reflected off of that object will go to your eyes, and in your eyes, in the retina, if I'm right, it's like this. In the retina over here at the back, that light has right now information of what that object looks like. So we can say that light is carrying the information of this object. This object. So then, or if we look at it this way, then we can say that we are looking in the past. Now, what do I mean by looking in the past? Even though it's way too less of the time interval, What do I mean by time interval? The gap between each time is so less. We don't even feel that time interval. And what I'm talking about is that we don't see this box. I don't know right now where it is, until the light from the bulb will hit this object and then come and hit my eyes. Till that time, till the light doesn't reach my eyes, this box doesn't even exist for me, right? So that means when it takes time for light to travel as well, because what's the speed of light? Speed of light is 299,792,458 meter per second. Okay, this is our speed of light, or in short 3 times 10 to the power 8 meter per second. So what I'm talking about is that because of the huge speed of light, the time interval between the time we see that object is reduced, and that interval, the reduction that time interval, makes us think that we are immediately looking at that box, but that's wrong. So the term that we are looking at the past is correct, because until the light will not reflect off that object, we will not be able to see it. So we can say that object, whether it's object or human, does not exist until the light is reflected off of it. Okay, so then we talk about, this is one point. Second point, light is a special kind of thing. Light is very special because you can say it has mind of its own. Mind of its own. What do I mean by mind of its own? Because light, the specialty of light is that it takes it takes the shortest time. Shortest? Not shortest, not what do I mean by shortest? No, this is wrong. It takes the quickest quickest path. This is its specialty. What do I mean by quickest path? Okay, let's suppose there are two roads. One road leads to this direction, one road leads to this direction, and who is over here? We have light traveling. Now, this light will either take this path or this path. But then, if this path has more traffic, there's a lot of traffic here, what light will do? It will take this path. It will take this path. Okay, now we will add one more point. This length and this length. Let's increase this to make it more comparable. Now look at this. The distance in this one is more. Look. What is it? The distance is more. But still, light took that path. Why? Even though the distance is more, that increase in distance and there's no obstacle in the way. That distance still is nothing for light. So it will take that path. So it makes sense because if this path is occupied, it doesn't have space, light will on purpose travel to the path which has less occupation or less obstacles, which will cause it to reach there faster, its destination. So, one more point, it's a fact. Light travels or takes the quickest path. Then, we have something known as what else do we know? When we talk about light is what is light? People say it's photons. What is this? Photons are discrete units of light. Photons. What is it? Photons are discrete units of light. Okay, so then one more thing. This is a very fun thing. Light in sun. Distance between sun and our planet Earth is a lot. And we know that light takes 3 times 10 to the power 8 meter per second. So this is how fast it travels. So this distance is distance between Earth and Sun, d. So T equal d over, not d, it's wrong, it's s over v, and s is certain value, the distance between Earth and Sun, over 3 times 10 to the power 8 meter per second minus 1, and this is t. What the answer you should get is 8 minutes. What? 8 minutes. So light takes 8 minutes to travel from sun to earth. Okay, so this is the time interval between for light to travel from sun to earth. Okay, if we look at this concept that light takes 8 minutes to travel from sun to earth, that could cause a lot of like consequences of, let's imagine sun disappears. What? Sun disappears, sun is gone, finished, it dies. Till 8 minutes. Till 8 minutes. We won't feel anything. We 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 won't we won't or we won't feel anything. Anything. Okay, so then what do we talk about then? So this is if sun dies. Okay, then when we'll talk about one more thing. What we will talk about? We will talk about light. Light's concept in reflection. What is reflection? This is basic thing in physics. That plane surface 90-degree. This is called normal, which is 90-degree angle to the surface. So the law of reflection is that incidence ray equal reflected ray. So what do I mean by incidence ray and reflected ray? The light which is coming towards the normal hit the coming towards the plane, sorry, this surface, plane surface, okay, the incidence ray coming towards the surface of this surface and hitting at a certain angle respect to normal, because 90-degree angle is the normal which what it makes with the surface. That incidence ray hitting the plane surface with a certain angle will equal the angle which it makes with which the normal makes with the reflected ray. Okay, so here we can say sine theta, sine, or not, we'll not take sine theta, we'll just take theta equal theta. Theta is angle. Okay, then what is light actually? Light, it is actually seven colors. Seven colors of Roy Biv. Look, Roy Biv. Here, this is red, this is violet, and so on. But then there's one more thing. There's something as spectra. Okay, there's something as spectra. Spectra is what makes us. It's a table which has all the colors and everything, waves, light wave. What is, okay? One more thing. Let's forget this for now. Let's forget this for now. We'll talk about what is light. Light is actually electromagnetic waves. What is it? Electromagnetic waves. And by electromagnetic waves, I mean if I make this, it's combination of horizontal and vertical wave, and one is one is magnetic line field and one is electric field line. So the combination of these two gives us light. This is what light travels as. This is what light travels as, and so on. So this is how light travels. Now then, how can we stop light? Huh? So how can we stop light? This is one small topic, then we will go, then it will be ending. So okay, how can we stop light? We can stop light using polarization. What is polarization? We know that light, this is horizontal, not horizontal, vertical, and this is horizontal. And a polarization, it's called a polarization paper, and in this it stops light certain properties. Let's suppose if this polarization has this, so it will not let the vertical part of the light to enter, which is I think vertical was magnetic, or magnetic. So vertical, it will stop this vertical. So if we have a polarization graph here, in result, after it crosses the polarization paper, only this is what we will see. So then there's one which is this. There's one which is this. Now this will do what? This will stop the horizontal part, which will cause, now what is light? Light is electromagnetic wave, addition of electric and magnetic. So if we make it a resultant one, that light goes from here. If I make it quickly, okay, now this one has first this and then this. The result you will get is no light, as it's stopped, it's closed. So if there's something on the other hand, or the other side of this paper, the one end paper, apple or anything like that, we won't be able to see that paper. In the next video, we will be talking about how we can see this paper, how we can let some of the light travel through. Okay, there's some things we have to cover.